Hello, everybody. Thomas Cook here. I lead sales and pre-sales for AnzoGraph DB for Cambridge Semantics, and I'm excited to take you through this next session on let me share my screen here. Driving AI and machine insights with knowledge graphs in a connected world. So just to set a little bit of context, data volumes continue to grow at a staggering rate, along with the demand for new and better insights delivered faster. New applications spring up all the time, and with them bring new siloed data repositories, locking the data within. All this complexity to the data ecosystem just continues to grow. This makes for a very costly and cumbersome process for data consumers and new application developers to organize and analyze the data. What's needed is a way to automate data preparation and facilitate better understanding of what data is available and how to access it. The ability to provide explainable AI and provenance of the data is also critical. Today, I'll show you how knowledge graphs and graph analytics will help you achieve those goals. The dirty secret of data science is that 70 to 80% of the time is spent on data preparation and feature engineering. And when I show this slide to data scientists, they typically chuckle and say it's more like 90 to 95%. The aspect of discovering the data, finding the data that's suitable, cleaning, conforming, and creating features is also the least enjoyable part of their job, according to this study. This is typically a very manual and laborious process with very few accolades. So how can we make this easier and make the job more enjoyable, reducing the cost of developing the models and applications and reducing burnout? So some of the traditional approaches to connecting all these disparate silos of information are data warehouses. They've been around for a long time. This is the original way of trying to put all of the data in a single place to get a single view, a canonical view of information. But the SQL data model is very rigid. It resists change. Anytime there is a change, it's very costly to implement a change to the schema or a change to a report. We have to go through a lot of testing, and they're very, very expensive. Are they going away? No. But are they evolving? Yes. Next, we saw the use of data lakes and the promise of the pristine data lake where you drop all of your operational raw data in there and just let people go and analyze it. This promise was never fulfilled, and the pristine data lakes were quickly termed data swamps. Next, we have Spark, very widely used and adopted today, but the data engineering efforts are very costly, complex, they lack lineage, and are oftentimes not repeatable. And an anecdotal story from a large telco customer we have, they said, we can give two data scientists the same problem and they'll come back with two different answers. And the reason is because of the complexity of where the data comes from, the rules to combine, and the quality, the data quality rules that they need to get those answers. They're always different. So how do we create a repeatable task, a repeatable way to get the answers that we need? Gartner last year in their top 10 trends of 2019 had this quote. They said, graph analytics will grow in the next few years due to the need to ask complex questions across complex data, which is not always practical or even possible at scale using SQL queries. So inner knowledge graphs. Let's talk about some of the problems that they solve and how AnzoGraph DB is uniquely positioned to create knowledge graph applications. So why graph? The ability to combine both structured and unstructured data into a single place and create relationships between those entities is critical. The ability to use natural language processing, which processes unstructured data, extracting the entities and relationships from that, is also a key element. Many of the popular NLP tools automatically create RDF data, which can easily be loaded into the database. The graph data model is also very flexible. It doesn't resist change the same way the SQL data model does. Refactoring is not necessary when there's a change to the application or the data sources. All this drives insights on the relationships as they're a first-class citizen in a graph database. We also support traditional analytics and also AI and ML. The feature engineering is a key element as well. And there's also many industry standard data models which support RDF and the graph model. FIBO for financial services, HL7 FIRE for healthcare. And then there's also many public knowledge graphs like Wikidata and DBpedia. And these continue to grow and expand. So what is a knowledge graph? Knowledge graphs are a connected graph of data and associated metadata applied to integrate and access an organization's information assets. The knowledge graph represents real-world entities, concepts, and events, as well as all the relationships between them, yielding a more accurate representation of a business's data. You can see the different views that exist of a knowledge graph, from an executive view to the data architect's view and the ontologist view down to the very granular level. AnzoGraph DB provides the ability to create this canonical data model to have a better understanding of the overall data as all of the data is in a single place, to make it easier to find and access the right data. Automate complex data preparation tasks and perform deep link analysis of complex relationships for improved insights. So let's talk about how graph analytics databases can support a scalable infrastructure for machine learning and data science. AnzoGraph comes with over 600 functions built in. Many of those are part of the Sparkle query language. If you're not familiar with Sparkle, it's a W3C standard that was inspired by SQL. So it's very SQL-like. It has a select clause, a from clause, a where clause, order by, group by, etc. All things that would be familiar to a SQL developer. Now, there are some aspects that are different, the ability to represent graph patterns and pattern matching and that type of thing. But all of the same concepts will be familiar there. But we've also added hundreds of additional functions to provide additional insights on the graph itself. So for instance, graph algorithms. So graph algorithms exploit information that's stored in the relationships. Algorithms like PageRank that shows you the most well-connected node in a network, or shortest path between two nodes using weights on the edges for cost or other probabilities or weights. Label propagation for clustering. We've also added a number of OLAP capabilities on top of the database, like cubing and rollups and windowed aggregates, the ability to create named views and named queries, conditional expressions. We've also built a user-defined extension interface that allows you to write your own custom extensions, either functions, aggregates, or services. And we've also used that same interface to deploy a library of data science functions, over 50 functions available to do feature engineering and data discovery, various distributions and correlation, entropy, primary component analysis, single value decomposition, etc. But you can build your own in any C++ or JVM-based language. We've also added geospatial support, which allows you to do location analytics across vast amounts of data in the blink of an eye. Do things like geofencing, defining a region and determining if a point or an event happened within that region. Proximity analysis, the ability to determine things like, is a fire station within 5 miles of a policy applicant? If so, then their risk profile would decrease. Things of that nature. We also support data virtualization. This is the ability to have the graph access non-graph sources underneath, but make it transparent to the user. We can support over 200 different data source types underneath the graph. So you can have your graph connected to sources like JDBC sources, HTTP, CSV, Elasticsearch, etc., and make that all transparent. You can either materialize that connection, have that data stored in the graph, or actually have a real-time pass-through query to those underlying sources. This really expands the breadth of our integration capabilities. We're also the fastest graph database on the market today, and we've published a number of different, we believe we're the fastest graph database on the market from anecdotal evidence and the various benchmarks that we've run. We've published a number of those you can download from our website. Some statistics I'll share with you here. We used an industry standard benchmark called TPC. It's used for databases. We converted that from a SQL benchmark to Sparkle queries, and we also converted that to Cypher and ran that those same queries on the Neo4j database. TPC-H is an OLAP version of this benchmark. So we saw 217 times performance improvement of those 22 queries running against Neo4j. It's not really a fair test because Neo4j is more of an OLTP database than an OLAP database, and this is an OLAP workload. But we are designed and optimized for high scale, high performance, large scale analytics, and that's what we're showing here. The second benchmark is the Lehigh University benchmark, and we were 113 times faster than the previously published benchmark there. We also ran the TPC benchmarks against Spark SQL and Spark graph frames, and we saw anywhere from 10 to 300x performance improvements there. And anecdotally, in a number of different competitive situations, we've seen performance gains similar against a lot of other competitors. So we're happy to be put to the test, stand us up, and we would love to be part of your pilot or proof of concept to test the performance and capabilities of AnzoGraph. So let's talk about some knowledge graph use cases. Underlying all of these use cases is the ability to do data harmonization in analytics. Enterprise knowledge graphs can support scientific data discovery, customer 360, supply chain, fraud detection, and others. The ability to do the harmonization in analytics is key driver for all of these use cases. Parabole has developed a cognitive AI solution using a knowledge graph that their software automatically generates. So Parabole provides a financial services product called alphaE, which takes a huge corpus of unstructured documents, news articles, corporate filings, and research reports. And using their optimized NLP technology, they create a knowledge graph with all the entities and relationships built entirely from these unstructured sources. With all the data inside AnzoGraph, they run cognitive models with lightning response times that help financial services companies find alpha and better understand investment opportunities. Remember, it doesn't matter how big the data is. If it's in silos, it can't be easily analyzed or used effectively. Repeated efforts of data discovery and rediscovery and then multiple copies of the data around an organization is a very costly problem and lead to a data swamp. AnzoGraph DB provides a cost-effective way of combining your connected data in a single place and make it easier for consumers to find and use what they need, along with fast, real-time insights. Interested to try it out? Download our free edition and try it today. And contact us if you'd like more. I really appreciate your time today. I know we're at the top of the hour, so I'll wrap it up and hand it back to you, Mary Dee. Thanks for your time.
Thank you. Thank you. That was, you know, a friend of mine yesterday was saying that he was surprised at how much interest there is in knowledge graphs from the data community, because in his mind, it was very closely associated with knowledge management and not as much with data. So in your view, who's the main group of people interested in knowledge graphs? Is it really the data community, or is it much broader than that?
Well, I think we are definitely seeing a shift in the broader data community. I mean, knowledge graphs are not replacing data warehouses today, but
Okay.
I think that is where things are moving because of the ability, all the reasons that I covered
Yeah.
in talk, the ability to easily integrate data, the ability to virtualize different data
Mm-hmm.
sources, and the combined additional insights that are provided from the relationships that are not easily stored and where you can't be stored when data is in silos. So
Right.
I think really it is the future, and we see that momentum moving toward that. I think historically, knowledge management was kind of seen as an academic exercise, and ontology and that type of thing was very academic. But part of the reason is due to the fact that graph databases in the past just simply could not scale. And we now have, massively scalable graph databases. I mean, we've scaled up to 200 nodes in one of our benchmarks, and so we can now handle any data volume.
Okay. And what's the future for data silos? Are we really going to get rid of silos?
Well, I think that there's a push, right, to have more of a data-centric architecture, right, and to have, instead of having applications drive the data of an organization, have the organization drive what data, and
Yeah.
then build the applications around that. I mean, it's not an easy shift, and because new applications come online all the time, this will not probably
Yeah.
change very soon. But I think that it's a philosophical and kind of a philosophical approach, but
Yeah.
many people are pushing for that.
Yeah. Yeah. I think it's fascinating. Really cool. So thank you
Absolutely.
very much. Thank you very much, Thomas, and thank you to
Thank
Podmesh
you.
as well.